Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the channel Chandan Physics. In this video, we are going to discuss polarization of dielectric and an idea of electric susceptibility. Let's begin. Let we consider a charged parallel plate capacitor. One plate is positively charged plus Q, another plate obviously negatively charged minus Q. Therefore, the electric field in between these two plates, let E naught electric field between the two plates. Consider a dielectric slab that is placed in an external electric field between these two parallel plates charge capacitors. A dielectric slab is placed. Since that dielectric slab is placed in between that external electric field, therefore, inside that of dielectric slab an electric dipole moment is developed, and that electric dipole moment in the way of negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, along the direction of electric field. And within that of dielectric, that portions cancelled out each other. Only the charge developed on the opposite faces of the dielectric. Here the net negative charge, there the net positive charges on the opposite faces of dielectric is developed. We figure out it. Plus Q minus Q electric field strength E naught inside that of dielectric slab. At that end negative charged, on that end positive charge. Due to development of these two opposite charges on the two opposite ends, there will be a production of electric field. That electric field direction from positive to negative, and that electric field is denoted by EP, electric field due to polarization. So EP, it is electric field due to polarization, and that phenomenon on which net negative and net positive charges are developed on the opposite faces of that of dielectric slab is known as polarization. Here the net electric field inside that of dielectric slab, therefore the net electric field inside the dielectric slab will be E is equal to E naught minus EP. Net electric field within that of dielectric slab. And the phenomenon of appearance of charges on opposite faces of that of dielectric slab induced by that of external electric field is known as polarization. Let me explain it. The phenomenon of appearance of charges on opposite faces of a dielectric slab. That is induced by external electric field is called polarization. The phenomenon of appearance of charges on opposite faces of a dielectric slab that is induced by an external electric field is called polarization. Here two important terms we have to know. One is free charge and another one is bound charge. Free charge the charges on the surface of plates of a parallel plate capacitor are called free charges. The charges on the surface of plates of a parallel plate capacitor is known as free charges. Another term as bound charges. Bound charge the induced charge on the surface of a polarized dielectric are called bound charges. That charges, the induced charges on the surface of polarized dielectric slab are called bound charges. That charges are known as free charges. These charges are known as bound charges. And the surface density due to that charges the surface density due to the charges is called surface density of free charge. Surface density of free charge. And that is denoted by sigma f. Surface density of free charge. Again, in case of bound charges, that will be surface density of bound charge. The surface density due to bound charges is called surface density of bound charges. And it is denoted by sigma p. Surface density due to the bound charge, or we can say that is the surface density due to the process of polarization. Surface density of bound charge. The phenomenon of polarization, the terms free charge, surface density of free charge, bound charge, surface density of bound charge, the net electric field inside that of dielectric slab. And the phenomenon polarization we can explain by the help of a polarizing vector. Therefore, the term polarization vector is introduced. So, what is polarization vector? The induced dipole moment per unit volume of a dielectric is called polarization vector. The induced dipole moment per unit volume of a dielectric is called polarization vector, and it is denoted by capital P vector. Mathematically, we can show it. Let us consider induced dipole moment of the dielectric, small pi vector, induced dipole moment of the dielectric, and volume of dielectric V. Then polarization vector, according to our definition, capital P vector, that is the induced dipole moment per unit volume, pi vector per unit volume V. Therefore, P vector is equal to dipole moment charge into distance between these two charges, that charge, that is qi, and distance between these two charges, let small d, that is the thickness of that of slab, divided by V. Here small d, that is the thickness of slab, and the direction of that polarizing vector from negative to positive. The polarizing vector, the direction of that polarizing vector in that of dipole moment sector from negative to positive. The direction of P vector is from minus qi to plus qi. The magnitude of that polarization vector, magnitude of polarization vector P is equal to QID divided by V, or P is equal to QID divided by volume area into thickness small d. Here as A is the area of surface of dielectric, dd cancel out, that is P is equal to Qi divided by A, charge per surface area, that is surface charge density, and that surface charge density due to the bound charge, therefore it is denoted by P is equal to sigma P. Hence the polarization of a dielectric is numerically equal to the surface density of bound charge. Hence polarization of a dielectric is numerically equal to the surface density of bound charge. Polarization of dielectric is numerically equal to the surface density of bound charge. Next, electric susceptibility. As you know, the polarization of a dielectric due to that of external electric field. So the polarization density is directly proportional to the product of net electric field inside that of dielectric and also the electric permittivity of the free space, that is polarization vector P directly proportional to permittivity of a free space epsilon naught and net electric field inside that of dielectric E vector, or P is equal to, we can use a proportionality constant. Let that proportionality constant is J E, where J E, that is the electric susceptibility of the dielectric, whereas E, that is the net electric field inside that of dielectric slab, it is E naught minus EP, E naught external electric field, EP electric field due to that of process polarization, and epsilon naught permittivity of free space, permittivity of free space, or we can say permittivity of air or vacuum. Permittivity means how charges response towards the medium, that is denoted by a technical term permittivity. Or In the form of magnitude, we can show it P as epsilon naught ja E or ja E electric susceptibility P divided by epsilon naught into E, the electric susceptibility. Polarization divided by permittivity of free space into net electric field. So, with the help of this video lecture, we understand the concept of polarization of dielectric, the phenomenon polarization, to technical term free charge, surface density of free charge, bound charge, surface density of bound charge, polarization vector, its mathematical form, and an idea of electric susceptibility and its mathematical formulation. So, with this useful and informative notes, let me wind up this session. Thank you.